let's continue. Let me open the table of content first. Okay, we are still in chapter 20, patching smaller tables, and still on homework simulation section. Okay, let me open that. Yeah, I guess the plan is to try perform translation with random seed 1 and then check out this question. Maybe something like that. Let me open my terminal emulator. Okay, okay, this is the script and this is the information. And let's try performing the translation here. Okay, random seed 1, I guess. Alright. Yeah, let's just translate the 3 virtual trace here. Oh, the page directory page like history 17. Okay, page 17. This one, okay. And then the virtual trace here. Virtual trace, okay. I think something like this, right? And then let me check. This is how we get the index. Okay, let me calculate that. Okay, ATM max. Yeah, let me add this. Yeah, maybe something like this. Shift 10. Okay, shift 5. Virtual page number max or bitwise max. Okay, virtual page number shift equal page table entry shift. Okay, alright. Looks like I haven't changed this. Okay, offset max something like this. Valid max. Okay, and then valid shift. It is 7. Okay. And then page frame number max. Page because of the assumption, right? In the readme here, 32 bytes. It is 2 power 5, right? That's why it is 5-bit. Okay. Max. And then shift 27. Index 27. Okay. This one, okay. 1, 2, 3, 4, 5, 6, sorry. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Maybe I'm not sure if I can do this. 27, right? Oh, let's check if this is true. One, 2, 3, 4, 5, 6, 7. I start from 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Wait, did I count it correctly? Let me check, I guess. 0, 1, 2. 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 24, 25. Oh, I mean by 25, right? 20, 21, 22, 23, 24, 25, 26. Oh, okay. This one 28, 29, 30, and then 30, 31. Alright. So it looks like what is it called? My film motion is not correct. Page 17, right? Yeah, I want to try Kent. Okay. 27. Oh, okay. Alright. Index 27, which is this one. Okay. I think PTA, right? Yeah, PTA, okay. Index A0. Okay. And then using the valid max. Or well, we can use this too, I guess. Okay, the leftmost number is 1, so it should be valid. Right. Okay. Yeah, I'm not sure if we really need a valid max. I mean, maybe just to be sure. Right, this is the valid max. Basically, we only get the first or leftmost bit here and removing the rest, and then using the right shift to get the value or something like that. Yeah, something like this. Okay, this is valid. And then get the page. FN max 32. Okay, so it looks like it is on page 32 for the page table entry. the page frame number max. It's basically this one. I think it is right. So with this one, we are removing this one, the leftmost digit or something like that. Okay, right, we are removing this one and retaining the rest of the information for the page frame number. Okay, it is in the page 32, getting the index, I guess. Max. Receive 3, okay. So it is on index 3 from the page 32. Right, let me check. This one is page 32. Or maybe should put that. Okay, something like this. Index 3, 0, 1, 2, 3, A1. The A address, page table entry address is A1 here. Now let's check the validness, I guess. Maybe we can do something like this. Okay, looks like it is valid. And then okay, we get the page, I guess. We fetch from the page. Yeah, we fetch from the entry page, the page entry, something like that. Yeah, in figure 20.3 here. Basically, after we get this one, we fetch the information, right? And then after we get this entry, we fetch the data from this entry trace, maybe something like that. So this is kind of, what is it? Where the data reside, maybe something like that. Yeah, I'm not sure what we should call this. Maybe we should call this, instead of PTA, we should call this page directory. And then this one is the PTA, page directory entry. Maybe. And then this one page directory entry. And then after getting this page, it is the page table entry, I guess. What is it? Page 53. And then get the physical address. Maybe something like that. I mean, let me check with random seed 0, the previous one. This is not valid, right? Page table entry not valid. This one. Okay. So maybe something like this. We get the, oh, right. Maybe page directory index, something like that. And then we got the page directory entry, right? After that we got the page table entry. Maybe or let's just call this page directory index maybe. Yeah, I'm not sure about the term here. What is the term that I should use? Something like that. Okay. Directory index. And this one is okay. Page directory index to get the PTA, paste table entry. It is invalid, right? Okay, and then this one. Okay, if anyone wants to try this out, the resource is in the description. Okay, and then I think this one, right? This is the PTA. Page 78. Yeah, maybe something like this. This is the yeah, maybe let's call this page directory. Okay. The page directory step here to get the page directory entry, right? And then in the page directory entry, when we got the information from there, we got the information for the page table entry. And then from the table entry information, we got the physical address. I am still not sure if we are able to get the value from this information. I mean, as far as I know, this is just the, what is it called? Just the memory address information. Didn't really have the value encoding or something like that. But again, I might be wrong. For example, this one, right? We got this physical address. So how did we know about the value here? I mean, if we take a look at the code, right? Well, we just get the value. There's a list. Where is it? Yeah, there is memory list, right? And then we got the value from those lists. But is that list is in here too? Do we expose that list? That I'm not sure. But from this, I assume we expose the list. Yeah, well, why don't I print that and see how it goes? Save memory. Yeah, maybe something like this. Okay. user. How do we cut to the conclusion of the value here? Okay, well, let's continue this first, I guess. Alright, I need to change the format here. This is not PTA but base directory entry or PTA. Okay, it is valid. After checking that it is valid, we need to get the page for the page table entry, something like that. 97, okay. 97, which is the PTA, and now okay, get the offset. This one max by offset max 20, okay. Offset, and then page 97, left shift page speed, it is 5, and then offset 20. Okay. T124. Decimal to hex. Is it related to this? To this page? For example, page 53. Let me check. Okay, we have this one. Alright. With the offset 28. Okay. The offset 28. Oh. Is that how we get the value? Wait a minute. Let me check. This one 0, 1, 2, 3. Okay. Wait. Oh, there is someone in the chat. Hello, chat. Marty. Welcome. currently I'm trying to learn about operating system by reading this book, Operating System 3 Easy Peace, and currently on chapter 20 on homework simulation, basically trying to understand about the memory management, or the virtual memory mechanism. Maybe that's the word. The virtual memory mechanism with the patching technique and with the multi-level patch table. So basically, let's say we have a specific amount of virtual memory, and then we are chopping that virtual memory into a fixed size page, right? Into a fixed size piece, I guess. And then we are using those piece as the memory to store information about the program, about our program, or something like that. And this is the simulation to to hopefully help us understand the concept of patching with the multi-level patch table. So let me show you the figure 20.3, I guess, this one. Oh, right, the resource is on the description, but I can put this in the chat too, so you can take a look at the book too. So basically, again, we have a specific virtual memory, right? And then we are slicing those virtual memory into a multiple piece like this. This is the linear patch table, right? So we are storing those pieces in the in the data structure, or in a place called patch table. Store the information here in the patch table, and there is linear patch table which is contiguous patch table like this. So basically, the pieces is side by side, right? Something like this. And then there's also the multi-level patch table. In this case, we have the 2-level patch table. This is one patch table, and this is, maybe we can call this a sub patch table. So we have a big patch table and smaller patch table, I guess. We usually call this patch directory, or at least in this book, we call this patch directory, and inside those patch directory, we have the pieces like this one. We have the memory pieces. So maybe we can think of it like directory, something like this, directory 1, and then inside this directory we have entry 1, and then entry 2, and then entry 3, yeah, something like this. And then inside those entry we have sub entry 1, 1, something like that. So entry 2, and so on. So that is the case, I guess, about what I'm trying to learn here. Yeah, I'm currently still looking at the simulation, trying to understand how the simulation work for the translation. Okay. Hello, Andra Wines. Bro, is there any visualization in this book? It's really confusing looking at the page 2 and page 16 number. There is visualization, but I don't think there is any visualization in the simulation. Yeah, the visualization only something like this, figure 20.3, something like that. But I don't think there is any visualization in the simulation. So we need to work with this what is it, base with this number. I'm not sure what the base it is. So yeah. Hello Ping Pong Poing, welcome back. My sleep schedule getting worse, by the way. I always wake up at 3 p.m. It is not healthy. Okay. Well, yeah, maybe I'm not sure how to fix the sleep schedule, you know. I mean, I might not have the best sleep schedule too. So yeah, I hope you get a normal sleep schedule back, Ping Pong Boy. Okay. Wow, that's too much. Go ahead, I can follow. Just imagine I won't get there. Well, I'm not sure if you won't get there, but you know, trying to take things slowly, I guess. But yeah, I'm trying to make this as easy as possible to understand by at least chopping this up into 2 characters like this. But yeah, for some people it might be tricky to understand. Okay, wait a minute. Yeah, just take your time, Andra Wines. You will get there eventually. Okay, I mean, I get confused a lot, right? like right now, I'm not sure where to get this value, right? Where is it? This value. So I'm trying to figure that out. How we get this value from this representation. I mean, the readme for the simulation is literally called this monstrosity. So the author also understand this is not gonna be easy to understand, I guess. So yeah, just take your time on the lines. Maybe you should understand low-level programming first to understand. Okay. Okay. Well, let's continue this first. Where am I again? Okay. Yeah, trying to numbering this byte, right? Assuming this two character representation as the byte. Okay, 4 and then 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, right? 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Okay, so this is the 28. So is the offset the index here? Interesting. So maybe we don't really need the physical trace here if we have this monstrosity as the memory dump, right? Okay, and just call the value like this. Let me check again. In this, the third one here, page 78. Okay, 78. This one. Alright, split this up into 2, and then what is the offset again? 21. Okay, is this the value? Let me check. Oh, okay. And well, let me just make sure if this is the correct what is it called? The correct index, something like that. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Oh, wait, did I miscalculate? 0, 1. Oh, okay. 4. Okay. Alright. Yeah, this one. Okay. Looks like we cannot find how to get the value there. Maybe. But I'm not sure. Is this the value in this physical trace? Or yeah, what value is this? I assume this is the value from this physical trace, but I might be wrong. Okay. Anyway, we finally have a way to understand or to get the value, I guess. Okay, maybe. Alright. So okay, after this one, page 97. Wait, let me go back again to this one. 97. Okay. Page 97. Or yeah, I can do this here, I guess. This 7. Split this up into 2 character here, and then to offset 20. Okay. Yeah, maybe this one, the value. If that is the case, maybe we don't really need to calculate the physical trace. Maybe. Okay. Okay. What is it? Yeah, trying out this one next. Vital test. Okay. The page directory here. page directory entry max, right? Okay, don't forget to write save that 26. So this is the index 26. Oh, okay, index 26 from this page, maybe this one. Okay, 0xt2 here, the what is it called, the page directory entry for that, and then file. Oh, I'm not sure if it is valid or not. Let me check. Okay, looks like this is valid, I guess. And basically just doing something like this. Valid save, right? Or we can also add the max just to be sure. What is it? Valid max. Yeah, basically trying removing the rest of this and only get the leftmost bit here, and then we got the indicator if it is valid or not. And then okay, looks like this is valid on page. Okay. I think, wait. Oh, page frame number max, right? Page 4, page 82. I mean, this is the page directory entry, and then page directory entry. Okay, T2 index. Index. Okay, I think this one, basically trying to get the page table entry. Okay, something like this, using the max to remove unnecessary bit, right? Okay, 1 2 3 6 9 12 15, I guess. Okay, let me. Okay, looks like that is 15. Yeah, we are removing the first 5 bit and then the last 5 bit. So it is something like this, the max. So so we only get the middle bit here. Okay, right. What is the index here? I think the PTA shift is 5 maybe. Right, 5 bit. From this assumption, 32 byte, right? Yeah, I'm saying this just to refresh my memory. Again, this is this monstrosity, like the author said, is confusing. Okay. Alright. Index 25 on page 82. Now let's search the page 82. Okay, this one. Okay, split this up into 2 characters here. This is 1 byte, this is 1 byte, so it's 2 characters here. Think of it like a 1 byte representation, and in this case we have a 32 byte, right? Starting from 0 here until the 31. Yeah, something like this. And then not that one. Okay, this one. What is the offset again? 25. Okay, looks like this is the 25. I guess PTA. What is it? C7. Okay, after that we got to check if this is valid or not. And we can just check the bit, I guess, the binary digit. Okay, looks like this is valid. Let me remove this and only take a look at the leftmost bit, the binary digit. Okay, this is valid. And then we need to get the bits. Okay, C7 max by PFN max. Okay, let me show, I guess, the PFN max binary representation here. Guess 15, right? Is it 15 or 8? this egg. Basically we get the rest of the bit from the previous bit here. Can we what is it called? The leftmost is for the validness, to check whether the address is valid or not, and then the rest is the page information, the page frame number, something like that. So there is that. C7. Okay, we got this one. Yeah, we need a decimal representation here. Page 71. Page 71. Then PTA page 71. I guess the index, the offset, I mean. We need to check the offset. Which is from the virtual address, right? Okay, what is the virtual address again? 6B22. And then the offset max. Only 2, okay. In case anyone curious, the offset max binary representation is something like this. Is it 8 or 15? I think 15, right? Basically we get the last 5 bit. I think in the script there is also the representation here, right? For the base directory entry, we only get the 5 bit, the first 5 bit here. For the page table entry, we got the middle bits here, and for the last one, for offset, we got the last 5 bit, something like that. Okay, the offset to page 71. 71, this one. Okay. Yeah, something like this. The offset too. Alright. Maybe the value something like 1A. Okay, 1A. I mean, if we want to, we can also calculate the physical address, I guess. It is, yeah, the page 71, page space is 5 if I remember correctly, and the offset to 2274. Okay, yeah, something like this. Maybe I'm back again. Good luck, Brutus. Have a nice day. You too, Ping Pong Boy. Have a nice day too. So why is it sometimes broken down into 5 digit, sometimes 4 digit? Is it still the same in hexadecimal? I'm also not sure. Yeah, I'm still confused about that too, right? Yeah, I'm not sure about the hexadecimal representation here. Like, well, we have this converter, right? But how do we decide that? How many bits we have? And why are we using like this one, 15 bit or something like that? I'm still not sure yet. Well, maybe we will find that out later on. Or maybe it is because of the architecture, like 64 bit. Yeah, I'm still not sure. I've also wondered about that. But oh, okay, this is decimal. I should swap this, right? Why are we using 5 digit here? But sometimes we are using what is it called? More than 5 digit, maybe something. Where is it? Something like this, 1A. Let me check. Oh, okay. Maybe it depends on this one. Not available. Okay. Oh. I think, wait, is hexadecimal base 16, right? I kind of forgot. Okay, this is 5 digit. Yeah, I'm still not sure. So that makes it 4 digit. Yeah, I mean, I'm still not sure about the hexadecimal representation here. Like, how do we get this 4-digit binary number with this hexadecimal representation? Okay, but yeah, I've also wondering about that. I mean, if I remember correctly, I even have a question, like, where is it? Chapter 18, I guess. How to read the hex number. Well, this is from the previous what is it called? From the previous chapter, simulation. Oh, okay, interesting. Wait, let me try 9. Also 4 digit. What about 7? 7 3 digit. Okay, interesting. And then 8 4 digit. Oh, yeah. I need to learn more about hexadecimal first, I guess. Is it because of the letters and number? I'm not sure. Yeah, there are 3 digits too, apparently. Right? If we use 7 here, we have the 3 digit here. And I wonder if we use 5. Okay, maybe not 5. 4. Oh, maybe 3. There is also 2 digit here. So yeah, something like that. I'm not sure how to translate that. Like way after 9 becoming A, I guess. And then maybe B. Right, this one. So maybe something like this. 9, maybe 1, or maybe 0. I think 0, right? Okay. 0 until 9, and then A, B, and so on. I'm not sure what letter to be used in the hexadecimal number. So from my limited or short observation here, something like this. Yeah, I need to understand hexadecimal too. Maybe later on, one step at a time, you know. Okay. I think let me copy this in the info here. With random set 0, and then this one. Random set 1. Okay. Alright. Alright, in case anyone wants to take a look at my notes, I guess you can check this out. Yeah, this is the notes that I've taken so far, or you can check the description. It is in the video description or the live stream description, I guess. Okay. Oh, I only translate this one. I haven't translated this. Okay, let me translate that real quick. Page directory, which index it is. Now let's put this in here. So I can reference this on the big screen. Okay, page directory, alright. The index, marks and then save. Okay, marks. And then save. Index 0. Okay, interesting. Is it index 0 or invalid? Well, I guess it is index 0 from this page with SDA. Okay, DA and then that validness. Okay, oh wait, not like that. Looks like this is valid. Okay, and then the page here. FN max page 90. Page table entry. Oh no, not page table entry, page directory entry. Okay, page 90. Do we have, oh no, not yet. Page 90, this one. Okay, page 90. Okay, page table entry marks. Okay, what is it? Not that one. Let me, no. This one, page table entry marks. Okay, let's save. That 30, I guess, is in index 30 from page 90. Okay, maybe this one. The A85. Okay, interesting. Is it valid though? Looks like this is valid. Okay. Wait a minute. Okay. Yeah, look like this is a valid paste directory entry. And then we got the page for the paste table entry. 85 page frame number max. Oh, right. 5. Is it page 5? Maybe. Okay. This is the paste table entry page, I guess. Page 5. Getting the offset. Okay. Offset max. Offset 31. Okay. And then 31. I guess this one, right? 31 0F. Okay. Physical address 5 shift bit speeds, and then add the offset with is 31. Okay, 121. Alright, maybe something like this. I'm not sure if this is true or not, but let's find out. Okay. Index 27 for this one. Okay. Paste directory entry content. Okay. It is valid. It is on the page 32. Right. And then we get the page table entry on index 3 here. This one, okay. The same, right? The page table entry. This also valid. 97 on the page 97. Okay. We take a look at the page 97 with the offset 20 and get the value. This one. Oh. Looks like I'm wrong. Wait a minute. Or maybe I just mistyped it. Let me check. Yeah, I forgot to copy this one. Okay. 97. Oh, I mistyped that. Okay. Alright, this is the right value. Again, from this information, right? And it looks like this is correct value. Okay, so basically that's how we get this value. At least now I understand how to get the value from this monstrosity of the memory dump. Man, that's a lot. Okay. Alright. I guess we will continue trying answering this question on the next session. Yeah, we have the translation from random seed 0 and random seed 1. So maybe we can take a look at the question to what is it called, to analyze the question 2 here later on. But yeah, let's continue this on the next session, trying to answer this homework simulation question on the next session. Okay, so that's it for now. Thank you for watching and see you next time. Bye bye.